Hello and welcome to GCSE Chemistry tutorial for topic C5 energy changes. This tutorial will cover part 1 exothermic and endothermic reactions. First of all, what do those terms mean? Exothermic is when energy is transferred out to the surroundings. That causes a rise in temperature of the surroundings. Endothermic is when energy is taken in from the surroundings, which therefore causes a fall in temperature of the surroundings. Here's some examples. Exothermic reactions include combustion, neutralization, oxidation, everyday objects such as hand warmers. Here's an example here showing the temperature increases when you add sodium hydroxide and hydrochloric acid, so therefore it is an exothermic reaction. Endothermic reactions include thermal decomposition, photosynthesis, citric acid and sodium hydrogen carbonate, and ice coolers. Here's an example of sodium carbonate and ethanoic acid. This time the temperature decreases, so it is an endothermic reaction. Let's look at them in a bit more detail. In an exothermic reaction, the products have less energy than the reactants, and that's because energy is released into the surroundings, causing the temperature to go up, as shown in this graph here. The initial rise in energy is due to the energy needed to break bonds in the first place to start the reaction. That energy needed to start a reaction is called activation energy. It's the minimum energy needed for the reactants to hit each other or collide and react. The greater the activation energy, the more the energy is needed to start the reaction. Endothermic reactions, this time the products have more energy than the reactants, as shown here. And that's because energy is absorbed, so the temperature decreases, but the energy actually increases. In terms of bond energies, in endothermic reactions, energy used to break bonds is bigger than the energy released by forming new bonds. In exothermic reactions, the energy released when making new bonds is bigger than the energy used to break bonds. You can also use energy calculations to figure out overall energy change of a reaction. You'll be given the bond energy of a reaction, and what you will need to do is calculate the overall energy change. As an example here, the overall energy change is the sum of the energy needed to break the bonds in the reactants, so on this side, minus the energy released when new bonds are formed in the products, this side. So the energy needed to break the bonds, you'll just use from this table here, so that's 678. Energy released by forming new bonds, don't forget you need to times this by 2 because there's 2 of them, so 2 times 432. And the overall energy change would be minus 184 in this example. Energy change is negative, therefore it is an exothermic reaction. You can also have a practical where you can measure energy transfer. Now, because heat can be lost really easily during a practical, you need to do this practical in a polystyrene cup and then place that cup in a beaker of cotton wool to insulate it. You also need a lid and a thermometer in the hole of the lid to measure the temperature change. So in this example, we're measuring the energy change of a neutralization reaction. You pour 25 centimetres of acid into the cup and record the initial temperature first. You'll then also measure out 25 centimetres of the alkali, in this case sodium hydroxide, but in a separate beaker, and record that temperature. Both temperatures should be the same at room temperature, around 25 degrees. Then you'll add the sodium hydroxide to the acid and put the lid on top, and then stir and take the temperature every 30 seconds for 3 minutes and record the final temperature. And then you'll look at the overall change in temperature. If the temperature is increased, it's an exothermic reaction. If it's decreased, it's an endothermic reaction. If you pause the tutorial now, give yourself 10 minutes to answer these questions. What's an exothermic reaction? That's when energy is transferred to the surroundings and so the temperature increases. Is energy released when bonds are formed or when bonds are broken? When bonds are formed. What is activation energy? The minimum amount of energy reactants need to collide with each other and react. In summary, we've looked at exothermic and endothermic reactions and a practical of measuring energy transfer.